Hey everyone, in this video let's take a look at question 91, decode ways on Leetcode. This is part of our blind 75 list of questions, so let's begin. In this question, a message containing the letters A to Z can be encoded into numbers using the following mapping. Basically A maps to 1, B maps to 2, all the way Z maps to 26. To decode an encoded message, all of the digits must be grouped and then mapped back to letters using reverse of the mapping above. There might be multiple ways to do this. For example, if we have, let's just take a look at the examples over here actually to better understand what the question is saying here. So essentially our string, let's say it's like 1 and 2, right? So there's two ways in which we can actually decode this. We might be able to decode this like 1 and 2, which map to A and B. We might also just be able to leave this as 12, which actually is just the letter L. So in this case, we want to return 2. So we want to return the number of ways we can decode this. For something like 226, well, we can maybe do 2 and then 26. So this is B and then Z over here. We might want to do maybe 22 and 6. So what is this? This is V and then F over here. We can also do something like, I guess, B and then F. So this is 2, 2, and 6. And this actually turns out to be the maximum amount of ways, which is 3. Notice we can't just do 226 all in one go. You'll notice here that the maximum is like till 26, right? So there's nothing that actually maps 226. The only thing, the maximum here we can actually map is just 26, which is Z in this case. Anyways, if we have like 0 and 6, then really 0, we can't do anything here because 0 is not even part of the mapping. So that's why we can't move forward. So how might we go about doing this problem? And I think really here we've done a similar problem in the past, right? We've done the problem letter combinations of a phone number. We've done the problem letter combinations of a phone number. And it's kind of quite similar to that one. In that one, we had like a number pad on a phone number. And maybe we were given like something like 1, 2, 3. And this, we were able to generate like all of the combinations that we could form. For example, 1 map to like A, B, C, D. So maybe if we just had like something like this, then 1 maps to A, B, C, D, 2 maps to like, or maybe I think 1 was A, B, C, and this was D, E, F. And so we would return something like AD, AE, AF, then like BD, BE, BF, etc. Something like this, right? So I think that's an approach we can maybe start off with. We can try to generate all of the list of combinations, right? We can try to generate all of the list of combinations. And every time we generate, maybe we just return the number 1 to indicate that we've generated one combination or like one grouping here. And then in the very end, we'll just return our answer. So notice that in this one, right, like we have to basically decode an entire string, right? And there can be multiple ways of doing it. And so if you kind of think about it, this is a backtracking type question because you first want to try to generate 1 and see what that gives you. Then maybe you can do 1, 2, or maybe you can just do like 2 alone. So those are a couple of different options you can take. And so if you really think about it, this is a backtracking type question. And so let's maybe approach it as such and see how we can start this off. So what can we basically do to start off? So let's see. First of all, S cannot contain any. S can only contain 0 and may contain leading zeros. Okay, that's all fine. But it looks like S cannot be empty, so we don't have to worry about the case where S is an empty string. Okay, so first of all, what do I need, right? So I need to create this mapping. I need like A to map to 1, B to map to 2, etc. But really, if you think about it, I need the mapping the other way because if I have 1, 2, then I want to know that like 1 maps to A, 2 maps to B. So how can we do this? Well, in Python, let's just define a dictionary here. And what I can actually do is I can do something like string.ascii uppercase, and then maybe I can do something like D at, what do I want? So this will be my index. So your index is equal to item. And let's just go ahead and print out the D here to see like what we get. You can see here that we're basically just going to be getting some sort of mapping, right? And ASCII, I need to do enumerate actually. Enumerate. So let's just go ahead and see like what we can print out over here. We can see that we get this mapping here, right? So 0 maps to A, 1 maps to B, etc. But I actually realized that A should be mapping to 1. So I need to increase this value by 1. And so now when we have it, we'll have the proper mapping. Okay, so we have the proper mapping now. So I'm going to go ahead and remove this. And now what? Okay, so now that I have the mapping, what I essentially want to do is I essentially want to count the number of ways in which I can decode this. And if you've done any of the subset questions with us, or permutations, or backtracking question, letter combination, the phone number, combination, sum, all these types of questions, they kind of follow the same format. So what we can actually do is, let's just go ahead and maybe define our variable here, which I will call res. So in the first part of this, let's just maybe see if we can generate all of the list of the decode ways, and then we can just return like the length of that list. So I'll generate them inside of this res array, and then I'll do my helper call, and then I'll just return the length of the res in the end. And so maybe res over here, like in this first example, res over here would be something like AB, and then it would be maybe or I guess like AB, and then here it would just be like L, right? So like that's what we're going to generate, and then we'll just return the length of this, and then we'll see like quickly how we can make it better. But how do we go about doing these problems? Well, these types of backtracking type problems, they're always the same solution, like in terms of like how you write the code. So I have my helper, and what are some of the things I need to pass in? Well, I need to pass in my string, right? I need to pass in my string. I need to pass in my dictionary. I need to pass in like a cur variable, which will like keep track of like the combination that I can form. I will pass in my res so I can add it on. And what else do I need? Well, I need some sort of index, right? I need to know like where I am in the list. And I think that's pretty much all we have. Okay, so now how do I know that I'm at my solution? Let's maybe like think of a base case here. So how do I know that like my cur has like completed and we've essentially traversed through the entire list? Well, basically that, right? Like if we traverse through the entire list, then we know that we have decoded our answer. So what can we do here? Well, we can do something like if, I guess, index is equal to the length of the string here, well, then we've decoded everything, right? So here I'm just going to add to res a copy of cur, and then I'll just go ahead and return. Otherwise, well, I haven't done it, so I can go ahead and loop through the string. So I'll do for I in range, and I'll start from index, and I'll go from index to the length of the string. So why do we start from index? Well, because like if we're considering like 226, right? If we consider 226, well, after I consider the 2, I will do a recursive call. Now I just need to consider these two, right? I don't need to consider this anymore. So I'm not going back to the front. I'm going one index in the front. And we've done this in our backtracking type question. So take a look at combination sum or anything like that. So if you're confused about this. But anyways, so we have this formula over here. Now what? Okay, so now we need to know whether like what our string is so far, right? Because for example, if we had something like, let's say our string was something massive like this, right? 2225. Now, let's say initially like I was over here, right? Or I guess like index was over here. Let's maybe do indexes over here. Index is over here, right? If index is over here, and so I will start off at this index. So at this moment, I can only form the letter 2, right? Here, I can form the letter 22. If I go forward, I can form like 222. So essentially, my I over here, I can keep track of like the word I'm going to form. So you can think of it as like word is equal to, what is it equal to? Well, it will be S from index to I plus 1, right? To I plus 1. Because index can actually move forward, right? So it wouldn't make sense for us to start at 0. We have to start at index. Okay, so now what's one thing we automatically know? Well, we automatically know, right? If word is like, the length of word is greater than 2, then it automatically cannot be like part of our dictionary, right? It automatically is not going to be mapping to any of the letters, because maximum we can have is 26. So if you really think about it, like if we check here, like if length of word is greater than 2, then we can not only like just skip this iteration, we can actually just completely break entirely, because everything after will just create like a word that is longer than 2 digits. So in this sense, like if we're greater than 2, then we'll just skip it. Otherwise, well, now I just want to check if like this value that I'm forming, if it's in my dictionary or not. And remember, my dictionary is in reverse. It's 1 maps to A, 2 maps to B, etc. So I can check like if word in dictionary, which is if word in dictionary, if this is the case, then what? Well, then let me go ahead and add it to my cur. So I will append the word, or actually not the word, I will append the mapping, right? The mapping. And then I will go ahead and do my recursive call. And then I will pop from my mapping. And this is a pop from my list. So this is how we always do the backtracking type problems. We go forward, we try the way, and maybe we go out of bounds, or maybe we mess up or something. So then we backtrack, and then we consider the next iteration. So maybe initially we start off with just looking at the value 2, and we see that it maps to A or to B. And then when we come back, maybe then we look at 2 and 2, right? So that's an example of like why we go back. So in this case, what is my helper here? Well, my helper, I'll do S, D, and then I guess cur over here, and then res, and the index will be I plus 1 actually, because we want to look at the next index. So we want to look at the next index that's formed. And so that's basically all there is to this. And then here, we'll go ahead and pass in s, d, cur is empty, res is res, and the index will be 0 here. So let me go ahead and run these sample test cases to see if we arrive at the answer. Okay, we do. Let me go ahead and submit it. And so this is actually correct, but it's going to be time limit exceeded or possibly memory limit exceeded. So let's take a look at how we can fix that. So first of all, you notice that here I'm like creating all of the combinations, right? So I don't really need to do that. All I need to do is like keep count of how many combinations we can form. So in that sense, if you think about it, I don't really need my array and I don't need my result over here. So I can get rid of this. I can get rid of cur and then result. I can also get rid of this over here. Okay, so then what? Well, in this case, if I reach the end, then how about I just return 1 to indicate that I've made a combination. And then here, basically, when I'm doing my recursive call, I will just add whatever the result of this is to my current amount of combination. So maybe initially, like I form 0 combinations, and then when I'm doing my recursive call, I will just go ahead and append, or I will add the remaining recursive calls, like whatever they return, as the number of combinations, and then here I will just return answer. So for example, if you start off here, then when I do my recursive call, this will return like, maybe it'll return, well, we need to like keep going, right? So maybe let's say like we start off here, well then this will return 1, right? Because this is just 5 and then there's nothing outside of it, so we'll return 5. And then when I come back here, this 25 will also actually return a 1, right? Because 25 is also a combination. But if you think about it, this 25, and then we add in this 5 here, so that's actually a total of 2 combinations we can form. So in that sense, like that's why we're adding here. And so if we're doing that, then we can actually just go ahead and return the helper result there. We don't need to go ahead and process anything or process the length of a sequence or anything like that. So we can go ahead and do this. And now if you take a look, we won't get a memory limit exceeded, but we will get a time limit exceeded because we're not caching and it's not the best solution here. So let's go ahead and cache this using memoization. And if I'm moving a little bit fast, it's because we've done problems like this before. So you can take a look at those problems, especially maybe take a look at word break. Word break is like kind of similar to how we're going to be doing this one. So anyways, let's just go ahead and cache this. So how do we cache it? Well, we need our memo. So we will define our memo here, right? Our memo. And then memo is just a dictionary, so I'll pass that in. Now, what do I need to cache? Well, what is changing here? What is changing is just the index, right? Just this I over here. So I will actually just cache this. I'll do memo at index is equal to answer. And then I can just return answer. And then basically, if index in memo, then I can return memo at index. And so this will be the cached approach. This will be the memoized approach of our solution. And we can see it's faster. But we can actually take this one step further and do a recursive, or not a recursive, a dynamic programming type solution. In that one, we actually won't do any recursion at all. So how might we go about doing this one? Well, in dynamic programming, essentially what we want is we want to transform our memo, like our cache, into a DP array. Okay, so let's go ahead and do that. So we have our DP array. Now we need to ask ourselves, well, first of all, what should the size of the DP array be, right? And what should be inside of the DP array? So if you take a look, what are we exactly caching? We're caching the index, right? We're caching the index. So if you think about it, the index, it can go from 0 all the way to the length of the string. So here, it would make sense for our DP array to be the length of the string, right? Because then what I could do is I could do DP, length of string, and actually here, I know exactly what to add in. I will just add in 1. So what does it make sense to start off our DP as? Well, just 0, right? Just 0. And think about what this means. What this essentially means is that at a specific index, I can perform, so DP at I equals maybe like 4 means that from index I to end, I can decode 4 ways. That's essentially what it's saying. So what do we want to return? Well, we would return DP at 0, right? Because if you think about it, DP at 0 would mean how many ways I can decode ways from current index, which is 0, all the way to the end. So it's the same exact thing we're doing here. We're just doing it in terms of a dynamic programming type solution. And highly recommend watch the word break video if I'm moving a little bit too fast here, because I just want to complete this video since it's very, very similar to word break. Anyways, So how do we go about doing it now? Well, now we have to go ahead and fill out our DP array. So we have to fill out our DP array for all of these indices here. Now, if you take a look here, I'm actually going in the forward direction when I'm doing recursion, right? So I'm looking at I plus 1. You know, usually when you do recursion, you might look at I minus 1, I minus 2, etc., whatever. Here I'm looking at I plus 1. And so what that means is that to fill up this DP array, I cannot just loop from left to right. If I loop from left to right, sure, maybe I'll be at DP at I, but then I have no access to what is DP at I plus 1. This might not even be defined yet. So because of this, we actually want to loop in reverse. We'll loop from the last element all the way to the first element. And so then we will fill up all the way and then fill up the first element and then return that. So let's take a look how we can do that. I'll do for I in range, length of DP minus 1, and then minus 1, and then minus 1. So essentially here, what I'm doing is I'm looping all the way from the last element to the first one. And so let's assume our string was something like 2 to 6, right? Initially, what's going to happen is our DP array is going to be four letters long, right? Or like 4 items long, because I'm doing length of s plus 1. And so this value over here, all of this is 0, but this value over here is essentially 1, right? Okay, so now my I will start off over here. And now what do I need to do? Well, now I need to form a string, right? Now I need to form a combination. Well, how can I do that? Well, I can have another loop here, which I will call j. And initially, first of all, j, we can maybe start off at I. We can also just start it off at I minus 1. But if I start it off at I minus 1, you can see the string is just 6. If I go back one more, you can see the string is now 26, right? If I go back one more, well, actually, I don't need to go back one more because this is completely invalid. But you can see that by starting j off, we are now forming another string. So we are doing the same exact thing we're doing here. We're just doing the same exact thing we're doing here, but from reverse. So what can we do now? We can do for j in range, and this will start off at I minus 1, and then again, it'll go from minus 1, minus 1. And actually, let's just go ahead and start it off at I. That's also fine. We can just start it off at I. Okay, so now that we have this, what can I do? Well, first of all, I can form my word, right? I will just copy like exactly what I'm doing here. So my word is equal to s at j and then I plus 1, right? J and then I plus 1. This might make more sense if it's like over here. You can see that j and then I plus 1, what this will essentially give me is like the ending, like just a string this, right? Just a string here. Technically, we could have also started off like at I minus 1 here, but that's fine. So we have this word over here. And now what? Well, now I'm just going to check the same thing. So first of all, if length of word is greater than 2, well, then I don't need to keep going backwards, right? I don't need to go all the way to the 0th index. Here I can just break the j loop. Otherwise, I will check if word in D, well, then what? Well, then we need to update our answer, right? So our answer is going to equal, well, it will be answer plus equals something, right? So what is our answer? Well, our answer, if you think about it, what is it going to be? So this 6 over here, this is what I want my answer to be, right? I'm updating this 6. So what I can do is I can do dp at j plus equals what? Well, it has to plus equal I plus 1, right? dp at I plus 1. So I can do dp at I plus 1. And so that's basically all there is for this question. We just went ahead, did the recursion, and then we copied it into our memorization and then our dynamic programming. So let's go ahead and run this. So I actually received one of this out of index, and the reason I'm getting that is it's because I'm starting off over here. So I should actually start off. So I should start off actually at minus 2 because we already processed this last element here. So that's why we're getting that. So let's go ahead and run it now, and let's go ahead and submit it. And we see we arrive at the answer. Perfect. And so just to kind of illustrate like what we're doing here, if you think about it, when I'm over here, when we're just considering the string 6, then I'm basically saying that, okay, 6 I know is in the string. So now I want to figure out how many ways can I generate this string here, which is like the empty string, which is just 1, right? So then I just add 0 here to 1, in which case I get 1 here. And then if I move back once more, then basically I can see that 26 is also part of the dictionary. So then I wonder how many ways can I generate this? Well, we can see this we can generate 1 way, and 26 we can also generate. So basically here the answer will be 1 plus how many ways we can generate this. So 2. And then we can't go back one more because then we would be like out of bounds basically. And so then we bring our I inwards, and then we repeat the same loop. So how many ways in which I can generate this? Well, actually here, if you think about it, we have the string like 26, right? So if we have 26, then we can generate 26 how many ways? Well, like 26 is part of the dictionary. And so then I want to know how many ways can I generate like this. So this one is just 1. So then here it actually becomes 3. And so then you can keep going backwards and working your way. And then when you do your 226, you can actually realize that we would just be generating 3 at the very end. So what is the time and space for this? Well, the time is just the length of the DP, so length of string. And honestly, it's mostly O of n, because this maximum is 2 iterations it goes back. So really, it's mostly O of n if you think about it. And then space is also just O of n because of this DP here. Okay, thanks for watching.